Spider has officially gone zero torque with the all-new ZT putter, built to minimize torque and keep your stroke on track. Here's how it works. Take these two putters, one's a traditional blade and the other is a mallet. Both have the shaft position near the heel, which is standard for most putters. But when you let either of them hang off the edge of a table to find the balance, the toe of the putters immediately wants to hang downward because the shaft isn't aligned with the putter's center of gravity. Imagine this concept when you're getting ready to hit a putt. With these lines representing the path, you want the ball to follow on the green. As you bring the putter back and through, the club head will naturally want to rotate, so you need to apply torque with your hands just to keep the face stable and hit your line. But now let's look at the all-new Spider ZT. Unlike the others, the shaft of this putter is strategically placed to keep the face of the putter square, meaning that if you let it hang, the toe of the putter would point up, and in practice that means that the face of the putter will stay square to the path without needing to apply torque or add another variable to your stroke. These zero torque putters are becoming more popular, but we didn't just force the Spider into a zero torque mold. Instead, we took what already made the Spider one of the most trusted putters in golf and layered zero torque engineering into that foundation. First up is the weight distribution of the classic Spider Tour X club head. In this X-ray image, the darker colors represent higher density metals, and you can see how engineers have pushed that heavy material all the way to the edges of the club. And this design choice isn't just for looks, it gives the club head a high moment of inertia, or MOI. It's kind of like walking on a tightrope. On its own, balancing is nearly impossible, but if someone hands you a long pole that spreads the mass away from your center, it becomes much easier to stay in control. It creates a higher moment of inertia, and we use the same exact concept with these putters. Next up is something called the pure roll insert. Most golfers don't realize this, but when your ball sits on the green, it's slightly pressed into the surface. It's only millimeters at most, but when you hit the ball, it can pop up, bounce, and skid before coming to what's called true roll. When we line up and chart that spin rate curve on a putt hit with a tailor-made mallet with the milled face grooves here in red, you'll see that the ball leaves the face with almost no forward roll. Then each time it bounces and hits the ground, it gains a little spin with friction, until it finally grips the green for the remainder of the putt. The problem is, in this skid zone, there's almost no control on the ball, and you get a lot of randomness in the putt. It's kind of like if an F1 car launched off the line with its tires skidding. There's no traction, no precision, just chaos until the wheels finally lock in with the track. To fix this, we developed the pure roll insert. At a glance, it just looks like grooves on a face, but if you zoom in, you'll see that they're actually angled beams. When they make contact with the ball, they flex, and then as the ball leaves the face, they release, instantly creating topspin. If we overlay that spin chart again, this time with a Spider featuring a pure roll insert, the ball starts its forward roll off the face, which minimizes skidding and reaches its true roll sooner, helping it stay on its intended line with more consistency. With this new ZT putter, proven Spider performance and pure roll consistency meets zero torque stability, something that we encourage all golfers to experience.